Hi all, we today looked at how to model the purlin, but we need to have a look at the catalog and the recommendations to effectively model purlins. Let's look at the Stramit catalog. This is the Stramit catalog. Lysor catalog is very similar. So I'll cover this Stramit catalog now for what is common between Lysor and Stramit. There are basically two types of purlins, which is the C purlin and the Z purlin. The depth and sizes are very similar for Lysor and Stramit, and you can see that the dimensions E and F for Z purlins are slightly different so that they can be lapped. If you look at the requirement for bridging, it says maximum bridging or bridging to cleat spacing to be 20 times the purlin depth. So that means if you have a rafter which is at a spacing of 4000 and a purlin depth of 200, that is a 200 purlin, for a 4000 spacing there is no need for a bridging. But if the spacing is more than 4000, 4300, then you will require one row bridging. It is not always that the engineer will specify bridging as per this catalog. If they haven't specified, you must raise an RFI. You should not go and put a row bridging without raising an RFI. The reason being, fabricator may not have priced in that bridging there. So it is necessary that you must raise an RFI. The other thing to note about lapped purlins is the overlap specification. How much to overlap is normally given in the member schedule, but as a general rule, it is 15% of the span. That is the overlap. These values are available in the catalog. So you must have a very good understanding of these catalogs, both Stramit and Lysor. They are very similar. The third thing to note about this purlin catalog is the cleat sizes. These are the recommended cleat thicknesses: 8 mm up to 250. Then if the purlin depth is more than 250, then you switch to 12 mm. The other thing when you lay out purlin is to make the hat this side on the upside. Modeling purlins like this is incorrect. For better strength, it is recommended that you model the purlins like this, that is this portion pointing up. When it comes to fascia purling, there are a couple of things you have to note. Most of the time, fascia purlins is installed with this portion vertical. And also the other thing to note is this hole center distance is 110 always. So even though your purlins are 150 or maybe some other size, the fascia purlin, this bolt center is always 110. The other thing to note is that you have to specify this angle. If you don't specify this angle, that is going to be a problem. Now, purlins normally cannot be rolled. It has to be made rolled by the manufacturer. So do not model curved purlins without a question to the fabricator, because that may become a special order. Now when it comes to bridging, you need to know a couple more things. The bridging is made up of generally a main member, then two end connectors, or it could be just a rod with threaded ends, or again it could be a turnbuckle with ends at the turnbuckle itself. There are various configurations. You have to look at this catalog, which I will upload, and study it properly, because this is extremely important. If you make a mistake, that is going to cost everybody quite a lot of money. There are a few more accessories you need to know about before you can actually model uh, purlins and bridging properly. They are these general purpose bracket, the guard bracket. These are mainly the two things, and of course these ones are used for either smaller purlins or larger purlins. How they are used I'll show you in the model. So you can see this is a general purpose bracket which is used to connect between purlins. So if you want to make a connection between purlins, a general purpose bracket is used. Now they come with pre-punched holes, but also because they are of not a big thickness, you can bend it. So if you look here, this is a connection between purlins. In this case, this is not a general purpose bracket, it is a specially bent plate, but many a times you can use a general purpose bracket and then bend it a little bit. See, when you want to connect purlin to purlin, use a bend plate or a general purpose bracket. General purpose bracket is preferred. Quite a lot of times you will have to have openings in the roof, like this one, maybe for a skylight or maybe some ducting to go through for whatever purpose. So what happens in that case is the purlins are running through, but you need to make a break in the purlin roofing. So what you do is you run purlins across, and this is what we call a trimmer purlin. So it's trimming the purlins and then giving some body around this sheeting so that the sheeting can be supported around. And at all these places we use general purpose brackets. In some cases where you may not know exact location of these openings, in that case what you do is you just provide trimmers with some extra length and also provide some loose general purpose brackets so that these things can be cut on site and suited. I'm going to send you this model for you to have a look at along with the drawings. What I would like you to do is look at this wall, which is at grid 1. Get rid of all these purlins. I'll send you also the drawing so you remodel this end wall with the purlins and the bridgings. Now ordering of the bridging is from a bridging list. Bridging list is a report created from the Tekla model. Let's look at one of the bridging lists. Let's select this one bridging and create a bridging list. To bring up the report, I press Ctrl and B and the list comes up, and to go to the bridging list I'm going to type in B a few times until I get the bridging list. So that's the bridging list. I select that item and then I'm going to create from selected items. Do you want to replace? Yes. So you can see that's the bridging list. Only one member because we only selected one, and it gives an assembly mark, a bridging name and a bridging profile. Something wrong with this report because it is swapped around. This is the bridging profile and this is the bridging name. And if you look at this one, see the name is in here, and that is actually the name. So this should be swapped around. This L and the B in here refer to the end codes, and the P in here refers to the member, the main member. So the P refers to this P, and if it's a S type, that is with a slot, it will be an S, and if it's an adjustable one, it will be a D. And the N codes refer to the C. So you go back there in the model, see the N codes L and then B here. So that is the N code B, which is a bolted bracket. The C is a clamp and L is a locator. So you have seen the video, so the picture is different for different type for Lysor and Stramit. We'll have a look at the Lysor videos. If you're using rod bridging, then you can bridge two purlins by using a rod between there and put a nut both sides. Here also another rod both sides. There will be two holes, so you can use one hole for this bridging and another hole for this bridging. But rod bridging do not use because it's more expensive to install and also cost more to buy. So if you look at this particular bridging, you can see there are two end codes. One is a locator and then the other one is a bolted end. So in this particular case, the bolted end will be this side because that's the last one, and this side will be a locator because a locator will require a clamp, which will be for this bridging, this end will be a clamp. And let's get that one. So you can see that there is a C there, and then the other well end is going to be a locator in this particular case. So this end again will be another clamp, so on and so forth. So if you look at the last bridging at the ridge, you can see this end is going to be a clamp, and here this side there is no locator, so it will be a bolted bridging here. And then when you look at this one, it is a rod bridging. So what this is, a bolted bracket here, and then the rod bridging will go through the purlin and will bolt with that. This you have to clearly understand. Now if you look at this one, it starts with a bolted bracket and it will go hook lock. That is a locator here, clamp bend, locator, clamp bend, locator, clamp bend, and it ends with a bolted bracket here. This type of guard system should have the bridging attached to a structural member, because otherwise the entire purlin will sag. It will sag quite a lot, like up to 150, 200 millimeters over 8 meters. So it is important that you attach this to a structural member. As an exercise, I am going to delete all these purlins and I will upload the IFC model. I will upload the drawings. I would like you to model all these purlins correctly and submit me a report as well as the drawings.